Problem 25. Here we have R equals to 1000 ohm, E equals to 250 volt. Determine the direction and the magnitude of the current in the horizontal wire between A and E. We have to find E at this branch. We have to find I to the right or to the left and the magnitude. Okay, here let me simplify the figure. You know, here we have point C and here point A and point E. Between A and E, we have nothing. So we can draw quickly a new figure in this way. Let me explain. E equals to 1 equals to 250 volt. It's here. R is here. And C and this one and this one are parallel, okay? Because the voltage VA equals to VE, okay? So it's the same point. You can put it like this. And here we have like this. We have 4 and 3R, and this one are parallel. The equivalent of 4 and 3 will be 1.71. Okay, how? Because let me label each one. Here we have 1 and here we have 2, 3 and 4. We can say R1 and R2 are parallel. So the equivalent 1, 2 equals to R1 times R2 divided by R1 plus R2 equals to 4R times 3R divided by 7R. Okay, here we get 12 divided by 7R, which is equal to 1.71R. Okay, this is the equivalent of the two parallel resistors. Okay, here we come to this figure. I need to calculate, as you see, I need to calculate E here. Now, before, let me calculate, first of all, take two loops. One loop here and one loop here. We can calculate I. You know, we choose an arbitrary direction of I. Here, let's take I1 will be up. Here we have I1 to the right. So we have I1 up, I1 to the right. And here we have I2 up and I2 to the left. In we get here I out. So here we have I1. Here we have I2. And here we have the summation, let's say I, which is equal to I1 plus I2. Let me put the positive and negative. We take plus to minus, plus to minus, plus to minus, and here, be careful here. No. Here we don't have a current. Here we have minus and plus, okay? And here we have minus, and here we have plus. Okay. And here also, at this one, we have I down from positive to the negative. Now, I take the first loop, left one, left loop. We start by the point B, from the point B to the point C, from the point C to the point A prime, from A prime, here we have nothing, to the point B. So we go from the point B, C, A prime, B, and we apply loop rule. Summation of delta V, we take delta V, BC, CA prime, and A prime B. Equals to 0. V final minus V initial, V final minus V initial, V final minus V initial equals to 0. Okay, we start by B and we finish by B. We have to look to the sign of the first one, this one, and this one. We start by the point B. We go from the point B to the point C. VC is at the negative side, so we have minus. The voltage at the resistance equals to R times I1. Okay, now we come from the point C to the point A prime. VA prime is at the negative side, we have minus. The voltage will be 1.71 R times I capital, which is equal to I1 plus I2. Okay, now we come from the point A prime. This one is A prime, the same A prime here is the same, to the point B. B is at the positive side, so we have plus times the voltage will be 250 volt equals to 0. This is the first equation. We can write this one here. Okay, now we take a second loop to the right side. This loop, clockwise loop, also we start by the point C to the point D, D to the point E, and here we have nothing between these 2 points, and to the end we go from the point A prime to the point C. So we go from the point C to the point D, D to the point E, E to the point A prime, and A prime to the point C. We apply loop rule where delta V equals to 0. We put delta V CD, DE, EA prime, and A prime C. Delta V CD plus delta V DE plus delta V EA prime plus delta V A prime C equals to 0. You know, between E and A prime, we have nothing. So V final minus V initial plus V final minus V initial plus V final minus V initial equals to 0. We start by C and we finish by C. We have to look to VD, VE, and VC, the sign. Between D and C, we go, look, we start by this point. From C to D. D is at the positive side, so we have here plus. The voltage equals to the resistance times I. Here we have I2. Now between D and E, VE, look here, VE is at the negative side. So we have minus 500. And now from the point A prime to the point C. C is at, look here. Now I am talking about this resistance. Here we have C and here we have C, the same point. C is at the positive side. So we have plus times the voltage at the resistance equals to 1.71 R times I equals to 0. This is the second equation. This one, you know, here we have I equals to I1 plus I2. Okay, you know, here I equals to I1 because at this node, here we have I1 in, I2 in, and I will be out. So equals to I1 plus I2. And here also I equals to I1 plus I2. So here we have I equals to I1 plus I2. We can say I1 plus I2 minus I equals to 0. So this is the third equation. Okay, as you see here, we have I1 and I2 as a noun. Here we have I1 and I2. Here also we have I1 and I2. So it's easy to calculate the value. Two unknowns and two equations, we can find I1 and I2. By using the calculator, we can find I1 equals to 10 ampere and I2 equals to 130 milliampere. We have two positive value, so we choose the right direction of I. We don't need to change the direction. We have the magnitude and the unit, and we have the right direction. This is about I1 and I2. Now, you know that the point A prime E is the same, and A, here we have, for example, A prime and E. Here we have A and E. We have nothing between, okay? So here from the figure, here we have the figure A, and this one the figure B. Here, as we calculated the value of I, the summation of I1 plus I2, we can find the voltage between C and A prime, okay? Or between C and A, or between C and E. It's the same. We said we have the same point. It's like this. So we can find from this figure, from the figure B, we find delta V between C and A prime, which is equal to R times I, which is equal to I1 plus I2. So like this, we can find the difference of voltage between C and A prime. Here we can be careful here, because as you see, here we have the positive side here, the positive side. So the positive side, the voltage of the point C is higher than the voltage of the point A prime. So we can calculate VC minus VA prime. Okay? Look, C is at the positive side and C is at the positive side. So the voltage of C is greater than to the voltage at A prime. So we can find V C minus V A prime, which is equal to delta V A prime C, final minus initial, which is equal the voltage between C and A prime equal to the resistance times the current, which is equal to I1 plus I2. We get here the value will be 240 R. This is the potential between these 2 points. So we have now the potential between C and A, also the potential between C and E. You know, delta V A prime C equals to delta V A C equals to delta V E C. It's the same. So we come back to the figure A. this figure, as we have the potential between A and C, we have the resistance, we can find the current easily. Let's say here we have a current I4. So we can say V, we can say here delta V between these 2 points, delta V A C equals to R times I. So I4 equals to 240 R in volt, okay? In volt. No, we have a mistake here. We don't have R here. Only 240, okay? So we come here, I4 equals 240 divided by 4R, it means 4,000. The value will be 60 milliampere. This is the value of I4. As you see, we come to this node. At this node, we have I1 up, we have I4 in, okay? So we can calculate easily I at this point, okay? We can calculate I. We can choose as we like this or the opposite, and we find the value. If the value like this is positive, so it's the right direction. If the value of like this is negative, so we have to put it to put the opposite direction. Okay. Now we choose this direction, and here already we have I1. Here we have I4, and here we have I. You know, I4 is in, I and I1 is out. So junction rule, IN, which is I4, equals to I out, I1 plus I. So we can calculate I, which is equal to I4 equal to 60 milliampere minus I1, which is equal to 10 milliampere. The answer will be 50 milliampere. Okay, this is the value of I at this wire. Okay, it's a positive value, so we choose the right direction. It's very important problem. Okay,